In this lecture, let us find basic feasible solution with column minima method. Now, it is similar as row minima method, but in the row minima method we started with the first row and allocate in the cell where the cost is minimum. Here we have to start with the first column and identify the cell in which the first having the least cost. Okay, and in this cell allocate the value as much as possible with respect to the demand and supplies as long as the demand or supply is exhausted. Cross off the column if the requirement or demand is exhausted, or row if the supply is exhausted, or both can be cross off if both are exhausted. Okay. If the first column is crossed off, then we can go to the next column, next iteration or next value. We have to see the next column and again see the list cell with the least cost and allocate in that cell and continue the process. Suppose in case the first column is not exhausted, that means the demand is not fulfilled by any supply, then a row is exhausted, then row can be crossed off, and then again we have to consider the first column again and allocate as much as possible in the cell with the second least cost. Okay, and then continue this process till the demands are fully satisfied and supply is also fully utilized. Okay. We are going to give the example with the same problem we have already earlier discussed with row minima and northwest corner method. Here D1, D2, D3, D4 are the distribution centers, S1, S2, S3 are the sources, and then S1, S2, S3 has got supply 6, 1 and 0, 6, 1 and 10. Demand has got demands are 7, 5, 3 and 2. Now, in this column the least cost cell with least cost is this cell. So, we are going to start with this cell. Okay, start with first column and this cell, and this cell has got requirement. This cell means this D1 has requirement 7 million liters and S2 the supply is only 1. So, we can a maximum we can allocate here 1 million liter here. So, as soon as we have put 1, we have put 1 already, a supply has been exhausted, we put a 0 here. And demand D1 has got met only requirement 1 million liters, still remaining 6 million liters here. Okay. So, we cannot cross off here, cross off the row, but we have still first column remaining. So, in the next stage we have to see the second least cost in this column. So, second least cost in this column is in this cell. So, we are going to allocate as much possible here with respect to supply and demand. Supply is 6, demand is 6. So, we can maximum we can put it here as 6. So, when I put 6 here, this becomes 0, supply becomes 0 and also requirement becomes 0. So, we can cross off this column as well as this row. Okay. Now, this row has been exhausted, this row has been exhausted, this column has been exhausted. We only have these 3 columns 1, 2, 3. Now, we have to see the next column is this column, and we have to put the minimum. We do not need to do anything because only the one element is there. So, we have to definitely put it here. So, there is the demand is 5, supply is 10. So, we put 5 here, this will be 0 and this will be 5 here. Then we go to the and this cross of this column. Then we go to the next column is 15 with 3, demand 3 million liter. So, we have to put it here 3, then this will be 0, 5 minus 3 is 2 here, and this column can be crossed off, and then we can, the last cell is this one. So, we have to put the demand is 2 and supply is also 2. So, we have put our demand and supply like this till the all supply has been exhausted and all demands are met. So, what is the solution? Solution is x1 equal to 6, x21 equal to 1, x32 equal to 5, x33 equal to 3 and x34 equal to 2. And total cost, if we can see, z equal to 2 into 6 plus 1 into 1 plus 8 into 5 plus 15 into 3 plus 9 into 2 and bracketed into 100 gives you 11,600. This is looks like, if you can compare to your earlier videos with northwest corner method, this is same cost as northwest corner method. Okay. So, this is how we can find out the column minimum basic feasible solution with column minima. These are the basic feasible solution. Thank you.